So this will be the end of section 4.4. There's only 4 problems left. I kind of wanted to put them in their own video just because they're a little bit different than the other problems, and I wanted to give you a break. As I look at the problems, there's problems 12, 13, 14, and 15 left. Problems 13, 14, and 15 look most like what I ask on a test, especially problem 13. So I'm going to do problems 13 and 14 and leave you problem 15 to do. So I'm not going to do problem 12. I'll just kind of scrub this one. And problem 13 I'll do, which is going to be a lot like a test question from this section. So a baseball player hits a ball, and I'm given a really small table, and I have a list of times and heights for the ball. So just like most of the word problems, at least at the beginning of this section, I have information, or I have times and heights. And what I'm going to do first is I'm going to graph the data, and then I'm going to try to come up with an equation that fits the data fairly well. So let me just go through the parts of this and kind of talk through the parts as I do it. So part A wants me to make a scatter plot of the data on my calculator. I don't need to make a copy on my paper. So to do this again, we need to enter the data. To get the data entered, the first thing I do is hit the stat button. And then I hit enter. So just stat then enter, because when you hit stat, the edit in the 1 is highlighted. Now when I hit enter, I see my lists. I'm going to put the times in list 1 because they're going to serve as the x's. And I'm going to put the heights in list 2, which are going to serve as the y's, just like they did in the earlier problems. 2 ways to clear out any lists that I have in there. The safe way is just to scroll to each number and keep hitting the delete key. Every time you hit a delete key, it deletes a number. The dangerous way is to go up to the top of the list and hit clear and then enter. It wipes out the whole list, but if you hit delete there, it deletes the whole list. So now in my X column, I'm going to do the times of 1 second, 2 seconds, 4 seconds, and 5 seconds. Arrow over to the Y column, and I'm going to do the height of 5 feet, I imagine. Doesn't say, but I'm assuming that's feet. 50 feet, 70 feet, and 10 feet. So this ball is going to go up and down. And now I'm going to plot this data. So I've entered the data. Again, to enter the data, you hit the stat button, you hit enter on edit, you delete any number that's in the list already, and then you type in the correct numbers. Once you have the correct numbers typed in, you hit the second button followed by the mode key. That's second and quit. And now I'm going to make a stat plot. So I'm going to turn my stat plot on by hitting second and then y equals. Now I'm going to hit enter to get this plot 1 on. So I'm going to hit enter, and then my cursor was blinking on the on. That's all I need to get it. Get my cursor blinking on the on and hit enter. And now the off won't be darkened anymore. The on will be darkened. And if I hit my y equals button, the plot 1 is on. I better clear this function out. And let me graph the data. So part A says make a scatter plot of the data on my calculator. I'm going to hit my zoom button, go down to option 9, I think it is. It says zoom stat, and hit enter. And now it's going to graph the data. And this data kind of feels like it's going to look like a parabola. It goes up, and then maybe it comes back down. It doesn't feel like a line. Done with part A. So this is just C calculator. Part B wants me to use my graphing calculator to fit a linear function, doing linear regression to the data, and a quadratic function to the data, which is going to be a parabola. And then I need to decide which equation is best. So for part 13b, I'm going to come up with 2 different answers. I'm going to come up with an equation of a line, and I'm going to come up with an equation of a parabola that fit the data as best as a line can fit the data and as best as a parabola can fit the data. To get the equation for the line to fit the data, we hit the stat button, we arrow right to calc, We arrow down to linear regression. We hit enter, and then we do second and 1 for list 1, comma, second and 2 for list 2, comma, vars, y-vars, enter on function, enter on y1. Now when I hit enter next time, it's going to give me the equation for the line. It says the equation is y equals ax plus b, but a is 3, so it's going to say the equation is y equals 3x plus 24.75. That's an equation that's a perfectly good answer for a linear function to fit the data. If I want to make this look like the equations that we got earlier, I might change the y to an h because the y's are the height of the ball, and I might change the x to a t because the x is the time in seconds. So this would be the linear equation, and look at the r. The r for this is 0.17, and we made a comment earlier that r's of 0.8 are better, are good fits. R of 0.17 is a horrible fit. When I graph this, the line, I mean, it doesn't even get close to the points. It's not a great fit at all. So, done with half of part B, I use my graphing calculator to fit a linear function to the data, and that's a cruddy function. Now I'm going to fit a parabola to the data, and to do that, to fit a parabola to the data, I'm going to go stat, arrow over to calc, and this is going to be called number 5, quadratic regression. A parabola is called a quadratic equation. So I'm going to do quadratic regression and hit enter, and then second and list 1 for the x's, comma, second and 2 for list 2. And I have my choice. I'm going to go comma. I can put this equation in y1 and delete the line, or I can put it in y2 and leave the line there. Let me put it in y2. So now I'm going to go vars, y-vars, hit enter on function, and let me put this in y2 as opposed to y1, so I won't delete the line. So now my calculator says quadratic regression, and come up with an equation of a parabola, use list 1 for the x's, list 2 for the y's, store it in y2. Now when I hit enter, it's going to give me my equation. It says y equals ax squared, but the a is negative 17.5, so it says y equals negative 17.5 x squared, and then plus bx, but it's going to be plus 108x, plus c, which is going to be minus 89. The equation of the parabola that I'm going to write, I'm going to change the y to h, which is the height, is negative 17.5 t squared, t for the time instead of x for the time, plus 108t minus 89. Look at the r there. The r is 0.96 essentially. Because the r is bigger than 0.8, this is a much better fit. And when I hit my graph button, if I hit my y equals button, the parabola is stored in y2, the line stored in y1. Now when I hit my graph button, it graphs the line which doesn't fit the data very well, and it graphs the parabola. And look how nicely the parabola goes through the data compared to the line. The parabola is clearly a better fit. Let me clear out that line because I'm not going to wind up using the line. So I'm going to just go to y1 and clear it out. And now I'll hit my graph button, and I'll only see the data and the parabola that match the data. So part B is to use my graphing calculator to fit a linear function to find an equation of the line to the data and a parabola to the data. So there's my answer to part B. Part C, decide which equation is the best fit. Well, the parabola, the quadratic equation, is the best fit. I'll say the parabola is the better fit. The line is a horrible fit. The r was 0.1 something. Then it says graph the function of best fit with the scatter plot. You don't need to do this. Just say C calculator. Now I need to use the equation to find the maximum height of the ball. I think I can do this without any algebra. I have the equation graphed. The maximum height of the ball is going to be at the vertex. If I can find the y-coordinate of the vertex using my calculator, then I can answer the question without any algebra. And let me try to do that by going second, calc, The vertex is a maximum point because it's the maximum height of the ball. So I arrow down the maximum. I'm going to hit enter. I'm going to use my cursor to, I don't even know where my cursor is at right now. Oh, there it is. I get my cursor to the left of the vertex when it says left bound. And then when my cursor is blinking somewhere to the left of the vertex, it could be way down here or way up here. As long as it's to the left of the vertex, you hit enter. The word left bound is going to change to right bound. And that tells me to use my right arrow and trace to the opposite side or the right side of the vertex. And it doesn't matter how close you are to the vertex, but you just need to get the cursor blinking clearly to the right of the vertex when the calculator says right bound. Now I'm going to hit enter a second time. Then my calculator says guess. I'm going to get as close as I can to the vertex. I can't really even see the vertex because the equation's messing it up. I get close to the vertex and hit enter. And my calculator tells me the vertex is 3.08, which means at 3.08 seconds or 3.09 seconds it reaches its maximum height. The y coordinate's the maximum height. I'm going to round to 2 decimals. I'm going to say it's 77.63. And I didn't say the units were feet, but I'm going to assume the units were feet. So my answer for part E, without any algebra, because I have everything all set up on my calculator, the max height for this ball is 77.63. And if you don't put units, that wouldn't be wrong because I don't have units saying that this is the height in feet. I should have said this represents the height in feet. And I'll go through and change that when I get done with this video. So that's problem 13. That's almost virtually guaranteed to be the test question from this segment of the video. You might be able to do problem 15 without my doing problem 14. If you can, do problem 15, check your answer, don't even watch me do problem 14. It's a real similar problem. So this problem right here tells me after a patient takes some medicine, this tells me the concentration of the medicine in the person's blood in milligrams per liter. I'm not a nurse nor a chemist, so I just probably lifted this from somewhere. And it basically, for the 2.5 hours that after somebody took some medication, it says how much of this medication's in their blood. And you can tell it starts off at none of that medication's in their blood, and then it goes up and it comes back down. You're going to do exactly the same sort of thing. You're going to make a scatter plot for the data. So you're going to have to enter the time in list 1, the concentration in list 2. Then you're going to use your graphing calculator to fit a line and a quadratic function using linear regression and quadratic regression. You'll see which one has the better R. If the one that has the better R is the one you're going to use, it's going to be the quadratic. And then you're going to write down what the equations are. You could use X's and Y's, or you can make up letters that are more appropriate, maybe T instead of the X, maybe C in place of the Y for concentration. You're going to decide which one is better. You're going to graph it when you're ready to have the graph done. And then you're going to answer the question, what is the concentration after 1.75 hours? To do this, you're just going to plug in 1.75. I'll say for T, that means for the whatever letter you use for the time, and that will give you the answer. I won't have to find a vertex because this question doesn't ask anything about a maximum. If you can't do 15 right now, my 14 is just like number 14, or like number 15. So the table that I'm given in problem 14 gives the birth rate per 1,000 women. So for 12 years old, 1 out of every 1,000 12-year-olds has a baby. Oh, that's horrible. For 17-year-olds, 42 out of every 1,000 17-year-olds have a baby. For 22-year-olds, 106 out of every 1,000 have a baby. That's 10%. That's a lot. And then as ladies get older, they have less babies. So the first thing I'm asked to do is make a scatter plot of this data. So the X's are going to be the age of the ladies, and this is how many ladies out of 1,000 or women out of 1,000 have a baby at that age. So let me just plot the data, do y, I'll do y equals and clear out that function that's in there. But to enter the data, I go stat and hit enter and edit, and I could just type over the data. I can just type 12 17, 22, 27, 32, 37, and 42. I don't technically have to delete the data. If the list that I'm entering is longer than the list that's already there, I could just type over it. Or I could delete, 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 and start with a clean list. Doesn't matter. Double check that you have the data in right. So 12-year-olds 1 in 1,000, 17-year-olds 42 in 1,000. There's a wrong error right there. This should be 22, 106. 27, 117, 32, 100, 37, 48, 42, 10. So now I'm going to scatter plot this by going zoom and stat. And it looks just like a parabola. So the lines that we're going to come up with is probably not the best equation. So again, I don't want you copying any of these graphs. You can just say, see my calculator. And now part B, I'm going to come up with an equation of a line using linear regression and an equation of a parabola using quadratic regression to fit the data. To do that, you hit your stat button. You go over to calc. For linear regression, to find a line to fit the data, you go down to number 4 and hit enter. And then you do second in list 1, and then comma, second in list 2, and then comma, and then vars, y vars, enter, enter. And that's going to, when I hit enter now, it gives me the equation of the line. I'm going to round to 2 decimals. So the equation I come up with for the line is y equals ax, and I'm going to write that as 0.24x, plus b, which I'm going to write plus 54.21. And look at that r. The r is 0.05. r over 0.8 is good. r at 0.05 is horrible. This equation of a line, although you can find an equation for a line that's the best fit to the data, it's not a very good fit. And if I was writing this equation, I might say b for birth rate equals 0.24 times the age, maybe, a for age, plus 54.21. So I might make letters other than x and y that fit the problem. And the data that I'm given, the x's are the ages, so I put an a in place of the x, and the y's are the birth rate, so I put a b in place of the y. But you can use x's and y's if you don't like the picking new letters. Now I'm going to do, so I found the equation of a linear function to fit the data. Now I'm going to do the quadratic function, which is a parabola. Linear functions are lines, quadratic functions are parabolas, and I'm going to come up with an equation by doing quadratic regression. I'm going to hit my stat button. I'm going to arrow over to calc. I'm going to go down to quadratic regression. I'm going to hit enter, and then second and L1 for list 1, comma, second and L2 for list 2, comma, then vars, y vars, hit enter, and then go down to y2 to put it in a different line, and hit enter one more time, and it's going to give me the equation. I'm going to round to 2 decimals, and I'm going to use my letters A and B. So I'm going to, instead of y, I'm going to put B equals, the number that goes in front of the, what I'm going to use for a squared is negative 0.49, so I'm going to go negative 0.49, and instead of having an x squared, I'm using a for age, which is a squared, and then plus 26.75 a, and then the c is minus 245.60. So that's the answer for part B. And I have to decide which one of these is better. If I look at the r, that r is 0.94. That's way better, r squared, should I say. And if I graph this now, you'll see the line that's not such a good fit, and the parabola, that's a pretty good fit. So the parabola is definitely the better of the choices. Let me delete that line by hitting my y equals and clearing my L1. Now when I go back to my graph, it only is graphing the data and the parabola. So which line is, decide which equation is better. I'm going to say the parabola is better. And then graph the line, I'll say C calculator. Next thing I need to do is predict the birth rate of a 35-year-old woman. To do that, I'm going to use this equation and plug 35 in for B. So for A, I'm going to get B equals, the birth rate equals negative 0.49 times 35 squared plus 26.75 times 35 minus 254.60. This is going to tell me out of 1,000 35-year-olds how many of them are going to have kids. And so let me just do that from my main screen by going negative 0.49 times 35 squared plus 26.75 times 35 minus 254.6, and the birth rate's going to be 81.4 out of 1,000. So I'm going to say the birth rate for part E, the birth rate is 81.4. And then that's, babies per 1,000 women. Usually I ask the baseball question on this one, so for this group of problems. So the problem 13 that I started off doing is probably the most important one of these problems, but all of them shouldn't be too hard. So I'll flash your problem 15 back up there, just in case you needed that push of me doing 14 for you to get 15 done. So we're technically done with the section. All we have to do now is the review for the test, and that's what I'll do next. If you could do every problem on the review, you're going to be completely fine for the test.